Hello, welcome to my channel. We're doing question number 13, chapter 13, vectors. This is the last question of this chapter. Okay, so this is pretty straightforward question. Um, okay, uh, so um, a particle P is initially at point in the position of this and move with a constant speed of 10 meters per second in the direction as this vector. Find the position vector of after the okay. So the A part is that first we want to find the velocity vector of point P, right? Let me call it VP. We know that its velocity is 10 meter per second, speed is 10 meter per second, and in the direction of this vector, right? So a unit vector in this direction is going to be minus 4, 3, and we divide it by the magnitude. So it's 4 squared plus 3 squared. So this will give us a unit vector in this direction. When you multiply this unit vector, which is speed, which is 10, right? Now, this whole thing is going to be 5, 5 times, this is 2, so I have minus 8 and 6. This is a vector, meter per second. So this is the velocity vector. Find the, okay. Now we want to find the position vector. Position vector means OP, right? With respect the reference of the origin. So position vector was 13 and 10 at time 0, and speed or velocity is this one. So plus minus 8 into 6 times t. So this will give us the position vector of point P after time t. So this is in meters. Okay, now as P starts moving, a particle Q starts to move. So this, okay. So now we know that the position vector of another point, another particle OQ, this is given by minus 80, 90, and plus 5, 12, T, right? This is the position vector of another particle Q. So second question, part B, is that write down the speed of Q. Okay, so you can see the velocity vector of point Q. So velocity vector of point Q, this is given by 5, 12, right, meter per second. But we need to find out its speed. So VQ vector, and I want to find its magnitude, which is the speed. So 4 is going to be 5 square plus 12 square, and that will give us 13 meter per second. Okay, and finally part C, it says find the exact distance between P and Q. Okay, so the distance between P and Q will be given by PQ vector, and this is the position vector Q with respect to P, I can say. Okay, so this is OQ minus OP. So what is OQ? OQ, I will write it as minus 80 plus 5t and 90 plus 12t minus OP, and OP is 30 minus 8t and 10 plus 60. And this can be simplified as minus 80 minus 30 is minus 110, and 5 plus 8 is 13. Similarly, 90 minus 10 is 80, and 12 minus 6 is 6. Okay, this is PQ vector. Now we need to find the distance between PQ. So we need to find the magnitude of this vector PQ, and that is going to be I can write it as 13t minus 110 and its square plus 60 plus 80 and its square, and this square root. So this will be the distance between the two. Now they ask us to find as the distance when t is 10. So we want to find this PQ vector, its magnitude when t is 10. So that would be, I will substitute 10 in here. So it will be 130 minus 110, its square, plus 60 plus 80 and its square. Easy. So you can see 130 minus 110 is 20 and its square, and 60 140, right? So this whole thing comes out to be square root of 20,000, which would be 100 under the root 20. So many meters. Okay. So I hope this is all clear. It was a easy question. If you ever have any question you want to ask, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.